Hello everybody, this is Mr. Bowen. Today we're going to be looking at the ALEKS topic, proofs involving congruent triangles with parallel or perpendicular segments. So we're going to be pulling in a lot of the information we've already looked at to try and figure out what's going on here. So we're going to use this given information to prove that our two triangles here are congruent. So what do I know? I know that SV, this big long line here, bisects RU. Okay, so that, now be careful here. I don't think this one's going to matter too much, but if SV bisects RU, which one's actually split in half is the second one. So that means that this is congruent to this. I don't necessarily know that SV is cut in half, so I want to make sure I'm marking the right stuff. And then I also know that RS is parallel to UV, so these are parallel here. So right now it doesn't look like I have a lot of information, but in reality I do. By knowing these are parallel, and which effectively makes RU and SV transversals, I know a lot of information because angle R and angle U then are alternate in interior angles, so that means these are going to be congruent. And S and V likewise, angle S and angle V are alternate interior angles of line SV as well, so they have to be equal. And then I also, if you want to use this as an intersection, know that these have to be equal because they are vertical angles. So we actually have quite a lot of information here. I know all three angles are congruent, which isn't enough by itself, but since I know that this bisects, then I know that these are congruent. I actually do have enough information here. So let's go ahead and list this out. So I need a statement and a reason section. Okay. All right. So first things first, let's go ahead and talk about our givens. So we know that SV bisects RU because that's given. And what information do I know about that? Why do I care? It's because I know that where their intersection point is T makes RT congruent to UT or TU, whatever, however you want to name that one, doesn't really matter. Okay, and that's the definition of bisect. Okay. All right, moving on to my next one. I know that RS is parallel to UV. That's given. And that's where I got a lot of my other information. Now, which ones we want to use here, it's kind of up to you. I'm going to ignore the vertical angle one because I only need two angles, but in reality, this will work regardless of which angles you pick. It just might change your reasoning in the last step slightly. So you have a little bit of leeway on how you want to set this one up because we have a lot of stuff. But I know that these are parallel, so I'm going to say that because that is the case from the given, that angle R is congruent to angle U because they are alternate interior angles. And then similarly I can say it about S and V. And I believe in ALEKS they use the really long version of if two lines are parallel, then alternate interior angles are congruent is how they do this one. So remember, you're always going off what you listed first. So I know they're parallel, so if they're parallel, okay, so don't fall into the trap of trying to do the if alternate interior angles are congruent, then the lines are parallel. It sounds very similar, but it is a very different meaning. So make sure you start with what you had first. All right, and line 6, we'll go ahead and wrap this one up. Angle RST is congruent to, triangle RST is congruent to triangle UVT by, looking here, I have used this one, and this one, so that would be my AAS theorem. Okay. And the only thing that changes if you decide to use the vertical angle If you use these two, it doesn't change at all. If you use these two, it'd actually be ASA, the side in between the two angles. But either way, it's going to prove it, and you'll be good to go.